Hi, everyone. This is Joe Dellicarpini, a meteorologist with the National Weather Service's Boston office and a Norwood resident, here to talk a little bit about the hail that fell in Norwood on August 15th of 2024. Well, there was a lot of hail. Hail actually up to the size of quarters was reported in and around Norwood, and the hail covered the ground in many locations. There was even some larger hail up to the size of golf balls that fell in southern Rhode Island, but most of eastern Massachusetts did see at least some small hail across much of the region that afternoon. Here's a look at the radar loop from the storms that produced the hail, and you can see as the loop begins again, the storms originated up near Nashua and Lowell and dropped southward, passing through the Norwood area around 4 p.m. In addition to the hail, there was also a lot of very heavy rainfall in a short period of time, which led to a lot of street flooding, not just in Norwood, but in many surrounding communities as well. So, how does hail form? Well, here's a diagram of a thunderstorm. First, we can see that there are raindrops that get kind of sucked up into the storm's updraft. And remember, the updraft of the storm is what leads to kind of the storm's growth. It's the fuel for the storm. Eventually, those raindrops reach a height where the temperature falls below freezing. So that could be, tens of thousands of feet up in the air. And when that happens, the rain actually freezes and forms into hailstorms. And this continues to grow as it circulates up and down through the storm. Eventually, those hailstones will get too large and too heavy and will fall out of the storm along with a lot of the rainfall. So that's when you see the hail actually fall to the ground. On the day, August 15th, just to kind of give you an idea of the weather pattern that was in place, this is up at around 18,000 feet, and you can see there's a big area of low pressure kind of over the Canadian Maritimes. And when we have low pressure way up in the atmosphere, it also is reflective of very cold air. So the freezing level was little bit lower than what it normally would be in the middle of August. And that's one of the ingredients we certainly needed for hail on that day. Now, if we look at the weather map from about 2 o'clock, not much really happening on the weather map. You see high pressure is over Pennsylvania. There's another area of high pressure over Canada, but there was a very weak front kind of in between that led to the development of the storms. And you can see afternoon temperatures here at 2 p.m. were well into the 80s. It was 86 degrees at Norwood Airport. So remember, very, very warm at the ground level in the 80s and very, very cold aloft. That's a pretty good recipe for thunderstorms. And we'll talk about how that influences hail in just a minute. So, looking at our hail formation ingredients, this is a look at some of the energy that was available in the atmosphere. And you can see the storms are starting to develop across the Nashua Lawrence area, which eventually moved in our region. But this generally tells us that there's a lot of energy available in that layer where hailstorms will form. Remember, below freezing. So, this is one indication that hail was certainly a possibility. The other is a change of temperature with height, which is the diagram here on the right, and it's showing some pretty good values. This is about 6 to 6.5 degrees Celsius per every kilometer you go up in the atmosphere. And again, that's reflective of the temperatures that were in the 80s that afternoon, along with very cold air up at about 18 to 20,000 feet. So the combination of having enough energy to produce the thunderstorms and these a lot of cooling higher up in the atmosphere leads to favorable conditions for hail. Now, on the radar, I've kind of stopped it here around 4 o'clock when the storms were producing hail in Norwood. You can see those storms right here, kind of between Westward and moving into Norwood, even approaching Walpole at that point. On the lower left, you can see some of the storm updrafts. Again, that's the air going up into the storm, that's lofting those raindrops to where the air is below freezing. So there's a pretty broad area with this storm, and that was allowing those hailstones to kind of recirculate, move through the storm over and over again and grow larger and larger. Now, the radar also has a couple of algorithms that we like to look at. One here on the top right is the probability of hail within a thunderstorm. And you can see the values are pretty high. These darker purple and even white colors show you chances of 80% or higher that the storm was producing hail. And we know for a fact that was certainly the case. It can also produce an estimate of hail size, but keep in mind this is where the radar is actually sampling the storm. And when the radar is sampling over Norwood, it's roughly about 1,000 feet off the ground. So it's not sampling at the ground level. It's actually a little bit above our heads. But in this case, you can see other hail estimates of 1 to maybe even 2 inches in diameter. Now, those didn't make it down to the ground, but they were likely up in the storm and melted a little bit on the way down. Again, temperatures are well into the 80s, so hail's not going to last certainly too long on its trip down toward the ground. So using the combination of radar and looking at the updrafts and using these probabilities really helps us as meteorologists determine what the threats are from a storm and how large the hailstones will be. So that's a quick look at our hail event, which was pretty impressive here in Norwood on August 15th. We don't see hail too often in these parts, and certainly not hail reaching the size of quarters or larger. So if you have any questions, feel free to reach out to me by email. My email address is joseph.dellicarpini@noaa.gov. Thanks for listening.